Hi, it's the Hawaiian Shirt Coder here again, and this is another Hawaiian Shorts episode. Ever wondered how you can restrict user input? Ever thought of using an enum in your C# code? In this video, we're going to have a look at that. Stay tuned. So my Hawaiian Shorts series are all about learning something quickly and trying to produce all the learning outcomes in one video. So today we're going to have a look at C# enums. Here are some of the learning outcomes from this video. So we'll describe what an enum is, and we'll say how we can use an enum to restrict user input so we only get valid values. We'll also show a trick that's been around with enums for a long time where we change the underlying numbering system to use binary numbers 1, 2, 4, 8, 16, 64. This is known as bitwise values, and that allows us to add more than one value to an enum. We'll show how you can add those in and how you can also check for their existence coming out the other side. So let's get on with it. So let me just walk you around the little program that I've set up to demonstrate C# enums. So I've just created a very simple console application called enum demo, and in the program CS file what we are doing is we are displaying out a holiday. So a holiday has a model that we've got over here in models, the holiday.cs class, and if we have a look inside that, it has a name property which is a string and a price of the holiday which is a decimal, and then it has a string that is the holiday type. The holiday type can be things like a beach holiday, a skiing holiday, family holiday, couples holiday, adventure holiday, all sorts of different types of holiday that you can have. And then finally down here I have overridden the toString, so when you call holiday toString it will concatenate together the name, price and the holiday type. And that's all we've got at this stage, all very simple. Back in the program CS we create a new instance of a holiday, and the holiday is in Malta and it's for 500 pounds, dollars, whatever the currency may be, and its class is a beach holiday. So if we just run this just to see what it does, you can see that it prints out the name is Malta, price is 500 and the holiday type is beach. So that all seems to work fine, but there's a problem with our holiday type. So like I said, our holiday type can just be a fixed amount of types. So over in my notes we've said it can be none, beach, ski, family, couples, adventure. Based on what we've got in our model at the moment, that information is captured in a string property. So there's nothing in our program to stop us doing something like this. Put in something that's completely nonsensical for that property and it will all still work. There we go, so holiday type is Apple. So a string type's probably not the best approach here, and this is where we can start to use something called an enumerator or an enum. So if I go over to my notes, this is what we've done so far. We've created our holiday object with a holiday type that is a string, and at the moment these are the only sort of values that we want, but we've just seen from the demo you can put any value in at all. So we want to introduce a thing called an enum. So if I scroll down my notes, Holiday type as enum. So the first question is what is an enum? So an enum is not a new concept. It's been around for a long time, not just in the world of .NET, also in Visual Basic and C and lots of other languages. But basically an enum, if I just close this out so we can see all this writing on the screen, an enum is a special class that represents a group of constants, unchangeable, read-only variables. So to put it more in layman's English, it's a nice readable name that hides a number under its implementation. So if we scroll down a little bit further, I've got an implementation of a enum. Here it is, and it is called holiday enum. It's called public enum holiday type. And each of the valid values that we will accept are written here. So we've got none equals 0, beach equals 1, ski equals 2, family equals 3, couples equals 4, and adventure equals 5. So the advantage of this is we can restrict the values that get input, but also they are nice and readable for the human, family, couple, adventures, and they make sense to the actual program because underneath they are an integer 1, 2, 3, 4 or 5. So let's implement this and see how this behaves. Copy this out, and if we go over to holiday types, which is in my enums folder that I created earlier on when I was playing about prior to the recording, and you can see now we have a public enum, an enum being a special sort of class that holds a load of constants that behind them have an integer value. So there we go. So we need to go back to our model now and swap out that the holiday type is a string and replace it with a holiday type enum, which is this one here. Just save that. There we go. So we've changed that property now to use an enum. So let's go back to our main program and adjust this accordingly. So this no longer makes sense, so let's comment this out. And then if we go holiday type, we will see all of a sudden that it gives us a fixed list of things that we can pick. So we can say a holiday to Malta is a beach holiday. Let's try this out now and see what happens. And that seems to be working. So name is Malta, price is 500, holiday type is beach. In the background, in terms of what the computer thinks a holiday type is, it thinks holiday type is 1. So that's, if this was getting stored off to a database, this is what will get stored in the database, 1. So that's a vast improvement, which we've got more control over what we're doing. If we go back to our notes, there's something more clever we can do with enums. If I scroll down my notes list, holiday types when a holiday can be more than one category. So for holidays, a holiday may be a beach holiday, but it may also be a family holiday or a couple's holiday, or a holiday may be a skiing holiday and also classed as an adventure holiday. So at the moment, this implementation only allows a one-to-one mapping for the holiday type, so that holiday to Malta at the moment can only be a beach holiday or can only be a family holiday. It can't be both. But with enums we have the possibility of changing that. so it can belong to multiple categories. And we do this through using an enum and using a bitwise. So what is a bitwise? So at the moment, our current implementation of an enum just has a name and an incremental number 1, 2, 3, 4, 5. By changing the number system to use binary numbers, we can now create a bitwise that will allow a holiday to belong to more than one holiday type. So let me just jump over to this other text file I've got to explain bitwise a bit further. So first of all, if you have a look at the key at the bottom of the screen, there are our various types of holiday: beach, ski, family, couples and adventure, and I've just put the abbreviation of each one so you can see which it relates to in my table above. So BE equals beach, SK equals ski, and so on. So if we use a binary number system, when we convert a decimal to a binary, we get a unique series of zeros and ones. So for example, the decimal value of 1, based on the binary system where each thing doubles up in numbers, we go from right to left, will give us 0000001. For decimal 2, 0000010, and so on. So we can create various combinations here, which will become more apparent in a minute. So let's go back to our notes and let's change our implementation of our enum. So we go back down here. Let's lift this one out, where basically all we've done is we've changed what the value of each of the labels is. So it is a binary number, so it will go at 1, 2, 4, 8, 16, 32, 64, 128, and so on. So we lift this out, go back to our enum type, and replace this. So at this stage, if we go back to our program should still work, even though we've changed our number system underneath. So let's just fire it up, just check it still works. And it's still beach. So underneath this time for beach, the value is 1. So if we want to make it that a holiday belongs to more than one category, because at the moment there is a one-to-one mapping, so the holiday to Malta is mapped to being a beach holiday only, but probably in a holiday brochure, a trip to Malta may be classed as a beach holiday and also a family holiday. At the moment with our current implementation we can't do that, but if we introduce the bitwise approach to our enum, basically changing our number system so it's using a binary number system rather than an incremental number system, we can do that. So remember that beach is 1 and family is 4. So back in our binary system here, what this will do in the background is 1 plus 4 in decimal number system is 5. So the underlying value in binary underneath will be this number here. So it will equal 101. So let's try and add that in now. So if we've already copied our implementation out here and placed it into our holiday type, which is here. We go back to our program CS and say change this so it's a beach holiday, and in order to add in a different type we use this strange syntax here. So let's just put this in again. So that's how we were before, it was just beach, but now you just have pipe, and then you can add in as many other ones as you like. So we just want family. So a trip to Malta is both classed as a beach holiday and a family holiday. Let's just run this up and see what it looks like. And there you go, you can see it is added up to 5, which does make sense because beach is 1, family is 4, so it becomes 5. If we also said it was a couple's holiday, then the overall number would be 1 plus 4 plus 8, which would give us 13. Let's just try that out. So we go back to our programs and we just delimit it with another bitwise pipe and say couples, which is this one. We run this up again, we're expecting the number to get printed out as 13. There we go. So it becomes very useful all of a sudden, so now we can assign multiple values in one property. However, there's one flaw in this, is all of a sudden as soon as it becomes more than one value, the system isn't intelligent enough to say what all of these are in terms of the nice friendly human label. Whereas when we only had one value in here, it would print out beach. There we go. So how do we overcome that? Let's put this back how it was. So again, that should now be saying 13. How we overcome that is by adding an attribute to our enumerator. So we do that by going back into the holiday types, and all we need to do in here is put this annotation, which is flags. As soon as we do that and run it up again, we get a nice human readable label. Holiday type now belongs to the categories of beach, family and couples. So that's good. That shows us how we can add various types into our enum. So how do we work the other way around and actually check if an enum value contains a certain value? So how do we say, oh, for this holiday object that we've got here, does this holiday object belong to the holiday type of a ski holiday, for example? Now how we do that is as follows. I've got another snippet here in my notes, is this bit here, so I'm going to copy this in and then walk you through it. So what we're doing here is we're saying in the holiday object, can you have a look in the holiday type property, and can you check, does this holiday type property, in whatever the number is, contain the enumerator value of ski? And if this, once it does its sums underneath, does not equal 0, 0 means it can't find a match, which means ski doesn't exist in there. If it's not equal to 0, it will say this is a skiing holiday, which in this example it isn't, because it is a beach stroke family stroke couple holiday. So at the moment, if we run this up, we're not expecting to see this message. So let's try this out. And we don't see the message. So let's tweak our holiday object so it is no longer a beach holiday. For some reason you can suddenly go skiing in Malta, which is highly unlikely, but will do for our demo purposes. So all of a sudden we're saying now, and it doesn't matter where it appears in the list, it will do the bitwise sums on it, and it says a skiing holiday, which ski is basically the integer value of 2 in our holiday type enumerator. Can 2 be gleaned from the bitwise value passed in. So at the moment our bitwise value passed in is, we go back to here, so that's 2, 5, 13 I think it is, if I've worked that out correctly. So ski is 2, family is 3, so that's 5. It's actually 9. So the actual value coming into our numerator at the moment is 9. Within that 9, can we derive out ski? And ski, if this is not equal to 0, which means it can't find it at all, it will say this is a skiing holiday, which this time the message should display. There you go, so that's finding it fine, and this would work with any combination. So you could also say, is it a skiing holiday and a family holiday, and it would be able to work that out, and you could do some conditional logic on that. We can just change this to a different one, so say, is this also a family holiday? And in this case it should say yes, it is a family holiday, so the message should show again. So there we go, so that's good. So that it's just thought this would be a useful sort of shorts video just to demonstrate something that's been around for a long time, but using bitwise with an enumerator gives you more options with regards to how one property can behave, where it can hold multiple values. So I'm the Hawaiian Shirt Coder. That's the end of this session. Please remember to like, subscribe, share with your friends. Remember, keep learning, keep exploring, keep developing, and I'll see you next time.